Good day, everyone, and welcome to the QEM Heroes webinar series. My name is Christine Wood, and I serve as the Assistant Program Director for the Heroes Fellows Program at QEM. And for more than 30 years, QEM has been a national catalyst for STEM education transformation and research capacity building. Currently, the QEM network serves nearly 900 colleges and universities and reaches more than 8,000 individuals nationwide. This webinar is part of the HEROES initiative. The HEROES program brings together former federal scientists to lend their expertise and support to the STEM research and education communities. Our fellows are here to provide tools and tips for navigating the funding landscape, developing STEM programs and partnerships, and improving talent retention in in-demand fields. We hope this series promotes engagement with our HEROES fellows and provides valuable resources to our participants. As a note, the webinar recordings and slides will be available in the QEM Resource Hub. By attending this webinar, you will soon be added to the QEM network and granted access to the Resource Hub. So look out for that email. Sometimes they go into your spam or junk folder, so please check. And I'm so proud to introduce our Heroes Fellows today. Dr. Aprille Ericsson is a trailblazing aerospace engineer known for many firsts. She is the first Senate-confirmed presidential appointee as Assistant Secretary of Defense for Science and Technology, overseeing a $2 billion enterprise. She was also the first African-American woman to earn an engineering PhD while at NASA Goddard. A Brooklyn native, she earned her BS engineering degree from MIT, ME, and a PhD from Howard University. Passionate about STEM advocacy, Dr. Ericsson mentors young minorities and women. Honored globally, she remains dedicated to advancing spaceflight and innovation. She continues to inspire future generations through education and leadership. And Dr. Yulia Goreva is a geochemist by training with a PhD from Caltech, specializing in earth and planetary sciences, excuse me. She previously served as a scientist at the Smithsonian National Museum of Natural History and as a scientist technologist at NASA's Jet Propulsion Laboratory. And Ken Wright retired from NASA after 40 years of federal service, where he most recently served as a senior policy advisor in the Office of Technology, Policy, and Strategy. Other roles during his career included Director of the NASA Inventions and Contributions Board, Executive Director for the Science and Technology Partnerships Forum, and Agency Lead for Innovation. Ken also served 2 years in the White House Office of Science and Technology Policy, where he led the National Science and Technology Council and lab-to-market activities. Career highlights include receiving NASA's Outstanding Leadership and Exceptional Service Medals and being inducted into the Academy of Distinguished Alumni for Virginia Tech College of Industrial and Systems Engineering. So without further ado, I'd like to turn the floor over to our presenters today. Thank you.
Thank you, Christine, and welcome everyone. Today we're going to be talking about decadal surveys. What are they and why are they important? We look forward to having you engage, and we'll make sure we save time for questions at the end of our discussion. We'll start off just by defining what are these decadal surveys we're talking about and what's the process for developing decadal surveys. They're quite extensive. And there's a long history of decadal surveys as well as the successes for these particular surveys. Then we'll give you some case studies about current and future decadal surveys and how you can become involved both with the various activities throughout the surveys as well as through workforce and cross-disciplinary recommendation, and then following with some closing remarks. So let's start with what is a decadal surveys. They're actually comprehensive reports produced every 10 years by the National Academies of Sciences, Engineering, and Medicine. And we talk about 10 years, that's a long time period. And this actually is a very distinguished position and activity to be involved with. So as we talk through this presentation, you'll see opportunities for you to become involved as well. These decadal surveys actually review a science discipline's progress in the previous decade and engages the community in ways to prioritize the science at the frontier, looking out 10 years into the future and advancing the highest priorities for science. It summarizes the input from the scientific community. So this is not just about a small panel that gets together, but the entire scientific community provides inputs throughout this particular process. And it proposes priorities for missions for the coming decade. As a former NASA employee, I know that the Science Mission Directorate is driven by the decadal surveys. So it's very important for NASA as well as NOAA and NSF also have different activities associated with the decadal surveys. And these serve as a framework for funding decisions, mission planning, and policy discussions, but the agencies are not legally bound to follow them because they have to have budgets to actually manifest the recommendations from the decadal surveys. But before we talk about the decadal surveys in the West, let's give a little bit of background on national academies because that's who drives these actual decadal surveys. So it started with the National Academies of Science as a private nonprofit society, all the way back chartered by Congress in 1863. So even back then, they were thinking about the future and how the nation needs to be in a leading position for science and technology. And it was mandated that the National Academy of Sciences actually advises the federal government on scientific and technical matters. Then the National Academy of Science figured we need more than just science when we're looking at this big picture. So they established in 1964 the National Academy of Engineering, and that was under a charter from the NAS, and it's a parallel organization of engineers. And as we continued to develop, they said we need some medicine involved with this too. So they actually developed the National Academy of Medicine. It was actually established in 1970, but then actually converted to the National Academy of Medicine. It was the Institute of Medicine back in 1970, but in 2015, it actually became the National Academy of Medicine. And the National Research Council actually is organized as a way that as an operating agency for all the activities in the national academies. Next slide, please. So let's talk about the process involved in terms of creating the actual decadals from the National Academies of Sciences. First, there's a committee formulation. This is where the leading scientists are convened by the academies, and this is a extensive process looking at some of the leading scientists, engineers, et cetera, from around the world, and actually coming together to form these steering committees and panels. Then they actually gather community input from white papers, participating in panels, community events, and these will be opportunities that my colleagues will talk about more as we get further involved into the discussion of how you can actually become a part of this community. And actually develop the actual decadal survey. This is a committee synthesizes all the input to produce a report which outlines the scientific questions, the mission priorities, and the research strategies that are associated with the decadal survey. And as you can imagine, this is a 10-year look out into the future. So at about 5 years into the activity, another committee comes together to review at midterm to evaluate the progress on the survey's priorities and see if there are recommendations that need to be made for the remainder of the decade. My colleague, Aprille Ericsson, is going to talk a little bit now on a specific example from the heliophysics community.
Yeah, so we just wanted to give you an idea of what we're talking about in terms of community input. And this shows the large input that was provided through community input papers. Particular members were invited to be on steering committees and panels and working groups. Those working group panels would have discussions with community members, both in government, industry, and at university or academic institutions. There were town halls at various conferences and workshops. I even know there were also surveys that were sometimes extended during those conferences. Um, there were additionally agency-supported workshops. For example, the Helio 2050, which was projecting, 50 years. Well, at the time it was probably like 2022, but focused on 2050. And then we also had the community initiated mission concept studies, papers, and presentations. You see the middle illustration that was actually created by input from the community, creating that word cloud that you see.
Thanks, Aprille. So we look a little bit here at the decadal history because, as I say, these go back to the first decadal survey was performed in 1963 in astronomy and astrophysics. So you can see there to the left the different domains or the different topic areas for the decadals, followed by the years that they have actually been published over time. So the astronomy and astrophysics decadal was actually the longest running decadal survey. starting in 1963 and most recent in 2020. And then the planetary science decadal was started out in 2003. And then there was another one produced in 2011, 2022. And you can see that sometimes it doesn't exactly map to 10 years. That's because this process actually takes multiple years to go through the process of developing the committees and getting all the reports and the community inputs and actually generating that report. So sometimes it doesn't exactly map up to exactly 10 years between the cycles, depending on how quickly or how slowly the committee went through the various activities. But you can see also heliophysics. Whoops, I was just going to say a little bit more. I can get off this one pretty quick. Heliophysics had three reports in 2024. Actually, was one of the most recent reports released in the heliophysics early area, followed by earth science in 2007 and 18, and then biological and physical science in 2011 and 2022. And one of the things that's significant about these decadals is there are a lot of data that goes into this, and it gives you a way to really look at that data over a longer period of time because there have been multiple decadals that can be built on. Next slide, please. Just a few examples of we talk about building on the decadals when we talk about the astronomy. Everybody's heard of the Hubble Space Telescope and the James Webb. All of those were recommendations from the decadal surveys, and they weren't just happenstance that they created in that particular order, where Hubble went up first and provided a bigger picture view of things, and then James Webb actually could focus in and look even further out at particular areas of interest. And same with the planetary decadal with the Curiosity and Perseverance rovers, where Curiosity was the first one to land, found some interesting areas, and then Perseverance had even more tools to be able to delve into areas of interest on the Martian surface. In addition to the ability to have the flying craft for the first time, Ingenuity, as part of that to really be able to expand the coverage for some of the region that were of interest. And then, of course, astrophysics decadal at Chandra X-ray observatory as well as a very, very large array. And the impact goes beyond just the technology to workforce, facility needs, et cetera. And that's where my colleagues will expand on that next.
Yes, so as Ken referred to, there are these return on investments that really occur from us either putting it out there that it will impact the science, but then what do we need to do in terms of infusing funds into various activities? And so one of the things that will occur is there is this trickle-down effect to programs like the Small Business and Innovative Research funding and topics. They're often identified that these are critical needs or technology needs through the decadal survey. And so I'm just highlighting in this particular slide one of the impactful ways that we saw return on investment with SBI funds that were sent to small company to help refine the beryllium fabrication capabilities. That company was Access Technologies in Cullman, Alabama. I actually would visit it to help for a future technology to be utilized for the ISAT-2 mission. So looking at some of the things that were being done with James Webb, also being able to help my colleagues with site visits as they began to fabricate those lightweight beryllium mirrors that you see in the upper right-hand corner. Those are gold covered, so they have a coating of gold. But particularly what is important about them was that beryllium allows us to have a material that is somewhat less conducive to thermal fluctuations. Um, and in the case for ISAT, they needed something lightweighted, and so these techniques were proven out for the James Webb Space Telescope missions. In addition to the technology development, because there was some overlap between the two missions, it was also realized that we really needed to train a workforce to be able to support the activities so that the missions could maintain their timeliness. And so Access Technology created a partnership with the local community college. The polishing of those mirrors is very an artesian type of form of work. And so helping to train the next generation was also a return on investment for these two particular missions. along the front of SBIR, there were also the infusion of money for the laser technology on Hubble. We later saw the impact of that for spin-off technologies for LASIK surgery. And we've also, we're already mentioning some of the things about the rovers, but there are 8 technologies that were impacted with SBIR funding. Wanted to also highlight one of the technologies, the battery systems. They are actually then passed on from generation to generation of rovers. And so Perseverance, Spirit, and Opportunity benefit from that small SBIR to Eagle picture. And that helped to create lithium ion and primary battery systems for those rovers. I think up next is Yulia.
Thanks, April. Excuse me. Yes, those return on investment stories like LASIK, optical fabrication, workforce, the 8 technologies enabling perseverance, they show how far the value of decadal priority travels beyond the original science. So now I want you to take a look at the missions that actually drive this value. Over the next few slides, 5 slides, promise no more, I'll walk through 5 missions. And we picked them on purpose. They span past, present, and future and kind of cut across agencies and continents. And each one shows a different facet of how a decadal priority actually plays out. Excuse me. What it makes possible and where it runs into trouble. So I'll start with the one that most people know. James Webb Space Telescope is an example everyone reaches out to show how decadal actually is working. But the real story isn't the pretty pictures. It's the decadal ranking that is arguably why this telescope exists at all. It was ranked number 1 in 2000, and then critically, Astro 2010 reaffirmed it as a top priority right as the program was in deep trouble. Astro 2010, in 2011, there was a very serious move in Congress to cancel it outright. So the fact that the entire astronomy community had twice and independently, because the committees are independent, twice and independently called it it's their single highest priority. That's actually what gave it the political cover to survive. That's the influence, not mandate, and we're going to talk about this idea a little later about decadal. So that basically nobody was required to keep funding James Webb, but the consensus, the science community consensus was strong enough that they did. The flip side is a cost story, and I don't raise it to dunk on the mission. The decadal estimated about $1 billion, and it came in around 10 and launched roughly a decade late. That overrun literally changed how we do business. It's what pushed the 2020 decadal to mature technology before committing to the next flagship. And you'll watch that payoff in our slide on Habitable World Awards Observatory in just a few slides. So notice also that this is not a purely American achievement. ESA and Canadian space agencies are full partners on Hubble. On James Webb. Scientifically, James Webb is, of course, already rewriting textbooks. It's the earliest galaxies, star and planet birth, exoplanet atmospheres, just to name a few. So that's James Webb. Next one, please, April. Okay, so if James Webb is a triumph, Perseverance is a cliffhanger. And a great illustration, a decadal priority playing out in real time. In 2011, planetary, of course, the sample return from Mars was planned for decades prior to Decadal came out, and but it's in 2011 planetary decade that I think it's called Visions and Voyagers. That's the one that named Mars sample return the single highest priority flagship. And in 2022, Decadal reaffirmed it. Perseverance, or Mars 2020 mission, is a step one in a huge campaign. It's Perseverance is not just a rover, but it's a sample collecting front end of a sample return mission architecture. So on its own terms, Perseverance and Mars 2020 has been spectacular. Been working on for 10 years on that mission. It's catching a rock cores in sealed, extremely sterile sealed tubes. These are the first samples ever collected on Mars for return to Earth. It made oxygen from Martian atmosphere with MOXIE. It carried, as Ken mentioned, Ingenuity, the first aircraft or a helicopter to fly on another world in a very thin atmosphere. And in 2024, it found that leopard sport chemistry that you may have heard on the news, exactly the biosignature adjacent feature that it was sent to look for. Now, I just want to make it personal for a second, because I had the odd fortune of working both ends of the story. On the front end, I was a sample return investigation scientist for Mars 2020. Through the design, testing, build of Perseverance and its sample collecting hardware and drills. Later, when Perseverance landed on Mars in 21, I was a long-term planner for the science and engineering Mars surface operations, so kind of deciding what to do, how to do it, how to collect science observation samples, and so forth. And then I crossed to the other side as a deputy principal scientist for Mars sample return, so kind of on the receiving side. And right up until it was paused. So most exciting and most humbling thing I worked on back to back. And working both ends taught me the honest lesson on this slide. The front end can go right and the back end can still stall. And missions, yes, I don't mean plural as in missions, meant to carry those tubes home, run into serious cost and schedule pressure. And a dependent review put it well over budget and pushed the timeline out. So NASA now is actively soliciting much cheaper architectures and private sector architectures. So this 2020 Mars sample return is a live test of the Decadal system. The community said, this is the number one. The first step succeeded brilliantly. And now the process, including the midterm review mechanism Ken described earlier, step 10. That's where we reckoned with whether and how to finish it. So, and one more connection. Yeah, remember April's SBIR slide? Yes, 8 of those small business technologies are flying on this rover. Next one, please. All right, so I'll pause here again because Rubin breaks an assumption a lot of people carry, that the Decadal survey means basically NASA missions. It doesn't. Look at the credit line, NSF and DOE with a French contribution. There's actually no NASA on this slide. The astronomy and astrophysics Decadal doesn't only rank space missions. It ranks ground-based facilities in the same report. And those are built and operated by NSF and the Department of Energy and can be other agencies as well. Rubin was the #1 large ground-based project in 2010 Decadal, and that single ranking anchored roughly 2 decades of NSF and Department of Energy investment. So that's one powerful thing about the model of Decadal surveys, the one prioritized list by community with multiple agencies leaning on it for guidance. On the telescope itself, it's genuinely current. First images came out only about a year ago in June 2025. And the 10-year survey starts this year. And I want to flag two challenges here. First, it's a perfect example of what Decadal can't foresee. In 2010, nobody worried about satellite mega constellations, right, that we have right now in the sky, and how those streaks may actually contaminate the images. So the 10-year plan was actually written for a world that was changing underneath it. And the second challenge is workforce and infrastructure story. Rubin generates about 20 terabytes every night. So to put it in perspective, that's roughly more than 300 times more data each night than James Webb collects in a day. So prioritizing the telescope was an easy part. So building the people and data systems to handle that flood is a much, much longer commitment. So hold that thought for a workforce discussion. Next one, please. So what? Surface, water, and ocean topography. It keeps the multi-agency, this multinational theme going and brings it kind of a different decadal. It's Earth science. It came out in 2007 Earth Science Survey as a priority mission. And like others, it's a long haul story. It didn't launch until the end of 2022. So 15 years, just think about that, 15 years after the recommendation. A decadal priority thus is a kind of generational commitment, not just a quick recommendation list priorities win. This one is a joint NASA French CNES, that's the French space agency, with contributions from Canadian and UK space agencies. So Earth Science Decadal also serves more than NASA. So it's a NOAA and USGS live in that world too. Because Earth observations feed operational forecastings and resource management, not just not just research. So it's inherently, Earth science is inherently global. What does is pretty remarkable. It surveys more than 90% of the planet every 21 days, measuring sea surface height and over millions of lakes and rivers and roughly 10 times the resolution, at roughly 10 times the resolution we had before. So this kind of a challenge of a technology maturation story that connects interferometry, that's the new K-band radar that it carries, with SBR, with technology needs with science. So that's the SBR that Aprille was talking about. It pioneered this carrying technology, and it's a technique that took years to mature and actually needed really careful calibration after the launch as well. So decadals don't just kind of outline missions. They pull new technologies in existence. And it's already paying off in ways nobody wrote in ways nobody wrote into a proposal. SWOT mapped thousands of previously unknown undersea seamounts. And that actually sort of tracked the river flood waves from space over the first time and so forth. So it actually produced a direct value for flood forecasting and is used right now today. Next one, please. This is last one of this batch. This is the Habitable Worlds Observatory. This is the currently in the technology maturation and preliminary design phase. So NASA continues to fund engineering proposals to refine specific structural, shield, mirror options before locking in the final design. And on the right here, it's not the mission. It's the 3 different concepts right now that are in the running. And I want to end on this, or at least to end examples on this slide, because HWO kind of closes the loop of where we started. So remember I said that James Webb overruns changed how we do business. Well, that's how the change looks like. The 2020 Decadal Pathways to Discovery made this infrared optical UV space telescope its top priority. That's now HWO. But instead of naming a fully baked mission and locking in a cost and schedule the way we did for James Webb, the Decadal deliberately recommended maturing the hard technology first. I think it calls NASA's Great Observatory Maturation Program. The community learned from James Webb and built the de-risking into the process. So Decadal isn't a static wish list. It kind of adapts on how missions evolve. So concept is roughly a 6-meter telescope designed to directly image about 25 potentially habitable worlds, targeted for, think about it, 2040s. At an estimated, and I'll say it lightly, but right now estimated it's 11 billion plus. And we really don't know what that plus is. So the cost is about the same order as James Webb, with a plus at the end, kind of reflecting realism that we live in. The central challenge of this telescope is almost absurd. So we want to see an Earth-like planet. And to see it, you have to suppress the glare of its star by a factor of about 10 billion, because the star is huge and very bright, planet is small nearby, you need to suppress that signal. So that technology doesn't really exist yet. This is why Decadal basically chose to mature it before committing. So stop back and look at these missions. I'm going to just take another minute that we went on. They span past, present, future. James Webb and Perseverance are delivering right now. Rubin and SWAT in their prime. HWO still on the drawing board. Span agencies, NASA, NSF, DOE. Partners with international agencies on different continents, span decades from recommendation to first flight is routinely like 15, 20, and or 30 years. Which means the single most important thing, well, not single, but one of the most important things in a decadal and decadal funds isn't a telescope or a rover or a mission, it's people. HWO won't return its first image until 2040s. And the scientists and engineers who build it and fly it basically in the classrooms right now, or in the labs right now. A mission that long only succeeds if the workforce behind it is healthy enough to carry it across decades. So it's a career building. It's a career building opportunity. That's exactly every decadal survey chapter actually now includes a chapter that was called State of the Profession, and Aprille is going to talk about that. And this is a health of the community itself. So let me hand it to Aprille, who will walk us through what actually surveys say about workforce and how we keep that pipeline strong and healthy enough to deliver the missions we just looked at.
Thank you, Yulia. So I have some personal experiences with quite a number of these. And so habitable worlds is one of those areas that we really looked at, changing how engineering and cost estimation was done. As she mentioned, there are 3 different concepts that are being reviewed. And so project managers at Goddard and elsewhere were included in these teams, so you can actually be embedded in the teams early in those concepts. I just want to mention that you could actually be on that initial design side as we try to wrap our arms around some of these very large observatories. I actually was a co-chair for the state of profession for the solar and space physics or heliophysics decadal study. We released that study in 2024. It took quite a number of years to work through the many different challenges and conversations. I already gave you an idea of how we reached out to the community. And in discussing with the community, we created a team to be part of the committee for state of profession. The four themes that we identified that were particularly important to unify and strengthen the field were demographics of the workforce, solar and space physics education, and then DEIA plus, and that plus stands for the A meaning accountability, accessibility, and a number of other A words that we thought were appropriate as part of the discussion. And then how do you expand on public outreach? You can read through the various bullets, but I wanted to highlight the recommendations that are in the lower part of the chart. So in the first category, we felt that you really needed to fund demographic data collection. Now, please realize that this is not just an issue for heliophysics. I've seen this issue of funding demographic data and the collection of that data for many different activities, particularly when engaging and looking at the STEM workforce. It's always felt that there just isn't enough data to make great comparisons or overarching themes. You can get some of the data, but there's typically some data that needs to be included that isn't always readily available. Then the second category, the discussion was that we really need to expand upon how we reach out to schools, universities, so K through 12, but also K through gray, and expand space science education. There needed to be additional faculty development in the geospace science areas, and then increasing opportunities for student research. Mind you, we started with this team and committee probably in 2022, 2023, but I feel that that last bullet is even more evident with this particular summer crop of some student internships. I saw a drastic reduction in students that typically would get hired and not having opportunities at some of the federal facilities and agencies, as well as in private industries and universities because of the funding cuts to basic research. Those often help to fund students in the summer. The next category, DEIA plus, we felt that you really needed to expand upon that research, really in helping to improve the quality of the proposals and plans and their evaluation, I think is particularly worth noting. I do see efforts that are continuing, but there was a gross reduction in DEI funding and funded proposals in the last 2 years. And then the last one is, I would say, if you're familiar with citizen outreach and citizen science programs, we felt that they really are very enabling. They help to educate the public, but they also help to increase the data flow because we have citizen scientists who are engaged in providing input. I particularly like the one for earth science, where you can make observations and send in data. And I think that is a great way for the community to be engaged, but potentially interesting students at an early age. One thing I also like to highlight is for this decadal, they actually helped to say how everything should be integrated to work together and ultimately deliver science. So to the far left, you have the Integrated Helio Systems Laboratory, which included not just the spacecraft that were highlighted, but also ground systems and data systems. You can see a list of different ways that these could be integrated with the different agencies. But one of the things I wanted to highlight also was not just the ground-based assets, which were highlighted, but also the space weather observation, which included the Air Force, which we had not highlighted as much as well. You heard NOAA, NASA, and SF but the military really do benefit from space weather observations as well. And then, of course, things like flagship modeling, which also begins to include things like AI, and then smaller platforms like explorers and CubeSats and suborbital missions. Um, just to give you an idea of sizing, the James Webb Space Telescope is one of our very, very large observatories, $10 billion. CubeSats are one cube is measured for us old heads 4 inches by 4 inches by 4 inches, or 10 centimeters by 10 centimeters by 10 centimeters is a cube. Um, we began to see a proliferation of CubeSats being developed at first universities and then later at agencies. Uh, Goddard began to do it with what we call a 6U, which is about the size of a boot box, and that runs anywhere from a 5 million to 10 million, which are much smaller costs, but able to give great science. And so we thought that the wide berth of platforms could be utilized in this learning laboratory, integrated laboratory. Driving that would be the collaboration and cooperation, the increasing in development of workforce, and of course the research tools, like I mentioned, AI is one, and then furthering our technology development. The last bottom part of the slide shows that how we could have these heliophysics as an example has a cross-disciplinary opportunity to impact astrophysics, planetary science, earth science, and the biological and physical sciences as well. And so these new technologies, even the mission architects could actually collaborate and help in some of the other decadal studies. And of course, there's always opportunities for future international collaboration. I think we could probably do tag team of all three of us on this chart because we're all kind of very aware of what we've done in the past, but we also know there are current decadal reports. Um, when doing research, both Yulia and I both came up with similar lists. So it was great to find that you can find these sources from different areas. But just to give you an idea of what are currently in the hopper and moving forward, um, the sciences that were listed before, and you can see the years between astrophysics and astronomy for 2020, planetary science and astrobiology from 2023 to 2032, heliophysics. They're already kind of out the hopper and ready to work on the next phase. And then we have the biological and physical sciences. And then earth science is working towards a 2029 survey. Um, and there are some hubs there, so some linkages that you could use to obtain any of the overviews and charts, also for summaries that were provided. I think, Eula, this next chart is yours. You're on mute.
Sorry about this. We can all team up on that. Basically, if you remember nothing else, remember the line on the top of the slide. Decadals give us a long-term, community-owned view of where the science is going. And that view is exactly what lets universities, agencies plan curriculum, hiring, infrastructure years ahead. This is sort of bridge from big missions to your students' careers and your institutions. So I just okay. Let me do this. I'll tie the bullets back to what we just saw, what you saw in the presentation. Community driven. Isn't an agency wish list. Decadals come from hundreds of white papers and hard consensus, which is why a ranking carries so much weight. Influence, not mandate. Nobody is legally bound to follow Decadal. But as James Webb showed, a top ranking can't keep a flagship alive when it would otherwise have been canceled. long time scales. James Webb was 20 plus years from recommendation to launch. HWO aims at the 40s. So these surveys shape entire careers, maybe not one subsequent. Cost and schedule realism. James Webb and Mars sample return both prove that even the number one priority can blow through its budgets. And which is why midterm reviews can described exist as basically the honest checkpoint for the process for the mission. So long-term payoff is the coordinated expertise that multiple agencies built over decades. So what's next is a full plate. We have, as Aprille mentioned, Planetary 2332. It's underway. And I think it brings to one of the most important points for everyone here on the call is to get involved, how to get involved. And the way to get involved is to write white papers. You serve on panels. You show up at town halls. So that's the community who writes the next Decadal. And thank you, Aprille. This has just came out yesterday. Was it yesterday or 2 days ago? This is basically a midterm review that Ken is talking about, review of progress towards the Decadal Survey Pathways to Discovering Astronomy. So Astro 2020 midterm review is here. And you can submit a recommendation of yourself or a colleague that can contribute to this endeavor. Go to the hub, submit. First of all, I would really advise you to go to the national board hub that Aprille was talking about. You can actually subscribe for email updates for all the calls, whether it's a town halls or white papers, and you will be in the loop of what's happening with Decadal. And for this particular one, maybe you can be involved. Ken, Aprille, would you like to say something in our closing?
No, I think we'd be open to questions. Christina, maybe are there any questions in the chat?
Not yet, but we have plenty of time to entertain questions. I just wanted to call your attention to this closing slide here before we enter the question and answer. Can you go to the slide with the QR codes, please, Dr. Ericsson? The various links on this page help connect you to the QEM resource network. So the QEM events page, you can sign up for future webinars. The Heroes webpage is a way to connect with our Heroes fellows and seek their services. And we also have a webinar feedback form that we would love for you to fill out to give us feedback on this webinar and what might interest you for future webinars. And for now, we have about 10 minutes for questions. There are multiple ways you can ask questions. You can enter your questions into the chat. You can enter your questions into the Q&A box, and you can also raise your hand to come off mute. I think I'll kick things off by returning to the observation about citizen science that Dr. Ericsson discussed. What kind of data do citizen scientists usually produce that ends up being valuable to the scientific community in deciding on priorities and developing the decadal surveys?
So I'm going to go to one of my favorite, which doesn't necessarily contribute to the decadal itself, but it contributes to the overall data. When my daughter was young, uh, we were very much into earth science. I mean, it's one of the things that Goddard does really well. And so I was familiar with, I was speaking actually at a young woman's event, and there was a group there from the Citizen Science for Earth Science, and they were requesting observations of clouds. So simply looking up into clouds or cloud formations and taking pictures, you as an everyday person could take your phone and take pictures of clouds and then upload it to the database. Um, there is another one that is not quite what you would think, but I know that it occurred because we had citizens that make observations. And it's one of my favorite spin-off technologies. Um, it's actually due to tracking of whales, so it's helping to track whales. It's a spin-off from a technology that does star tracking. So if you look up at the stars from a spacecraft mission, they can find their position and location with the star maps that are already loaded through these star fields. And the star mapping was identified as similar to what you see on some very large whales. The back of the whales have these unique patterns, just like your fingerprints. And so they are able to track the whales, but the way that they get the initial pictures or backs of the whales is through citizens taking pictures when they happen to observe them. So not just scientists, if you happen to be on a ship and doing a whaling viewing, you could take a picture of this and it would be added to the catalog of maps, and they would track these maps in that way. So I love NASA spin-off technology. It's really cool. But yeah,
That's absolutely fascinating.
Yes,
Thank you.
and if April talked about her favorite, my favorite is meteorite sightings. Because I worked on meteorites pretty much my entire career. It's called the Chipman spacecraft because that's actually sample that's being delivered. Of course, it doesn't compare from sample that we know exactly where it's coming from and characterized, but meteorites are absolutely awesome to learn about early solar system. So citizen science eyewitness reports are absolutely critical for pinpointing atmospheric trajectories and calculating potential landing zones of meteorites. So you have to do triangulation to know where the meteorite landed. So eyewitness reports provide time, directory, location, and angle of the fireball descent or fire shower descent. So when combined, reports from these multiple observers are triangulated to trace the object's path and where it actually landed. So that is only one of my favorite ones from citizen science.
Thanks. That's absolutely fascinating. I am mind blown.
Just to suggest, I'm not going to say my favorite one, but I do think that the citizen science site is something that all the educators should be, going to and having their students go to because that's a way to get them involved with real impactful things, and at the same time, learn about some of the great ways that we utilize that citizen science data. So.
Thank you so much for spanning so many topics from citizen science to student involvement to opportunities for faculty and researchers to get involved in the decadals. Thanks for a very informative talk. We will hold on for a couple more minutes in case there are more questions. Have a very nice comment of praise in the webinar chat. I'm glad you enjoyed the talk, Lucy.
And we look forward to feedback too. We always want to look for ways to have topics in the future that are interest to the group. So definitely give us feedback on this one as well as uh, areas of interest for future topics.
I don't know why I muted myself, but in the absence of questions, we will say thank you very much for attending our webinar today. We hope to see you at a future Heroes Fellows webinar, and we hope you enjoyed this talk. Thank you.